Thank you very much, everybody, for joining this session. I hope you're having a good conference so far. And the talk today is going to be about testing some crazy things and what we can do with new technology and automated testing. I've been very lucky for the last couple of years to start building my own tools and kind of working for myself, really. I've rediscovered the joy of coding, and because there's nobody to tell me you can't do this or this is not allowed, then we end up doing lots of interesting experiments. Some of them work out well, some of them don't. And I'm going to tell you about some experiments that worked out really well. So one of the first things that becomes kind of interesting to look at, I think, to set the stage for what comes next, is what we've been considering as best practices in automated testing and common sense in automated testing. And I want to challenge these things a bit because I think the new technology allows us to slightly break the kind of best practice, but still keep the principles behind it. So kind of whenever we look at automated testing and kind of things about best practices around testing, the whole idea of the testing pyramid comes across. And there are millions and millions of versions of the testing pyramid online, but generally the stuff that Mike Cohn defined a while ago, and the canonical version of that is you should have a large majority of your tests to be small, isolated, quick unit tests that are looking at discrete code units that are reliable, resilient, that return fast. Then there should be a smaller group of component tests or slightly more integrated tests. They are slower, they are more brittle, so that's why we want to have them slow. And at the top of the pyramid, we want to have very few end-to-end tests. That usually means very few tests that touch the user interface, that have anything to do with the whole application, because these things tend to be very brittle, they tend to be very slow, they tend to be difficult to maintain. So in terms of kind of the best practices that the testing pyramid has kind of taught us, we prefer very fast, very isolated small tests. We also want to focus the scope of the test, the risk in small code units. Most of the testing is done on small code units. Generally, the idea is to avoid integrated tests, avoid any tests that are non-deterministic, avoid anything that has to update frequently. And lastly, kind of anything that doesn't really return reliable results. Just don't bother automating. That's kind of where, as a community, we've been talking about best practices for the last 20 years. So I think, this paints a really nice picture for what we've been doing for the last 20 years. But these clouds, when you can see there on the top of the picture, when they're far away, then it's all fine. But once we start deploying our software to the cloud, the things become really messy. One of the things that becomes really messy once we start deploying our software in the cloud is the risk actually moves. So one of the tools I'm building with a colleague is a collaboration document editing, a mind mapping tool in a sense. And we have reasonably good client-side error monitoring. We have millions of clients millions of customers all over the world. And, people put stupid stuff in their browsers. They install extensions that interfere with our software for lots of various reasons. So we have client-side error monitoring. And we don't really act on every error there again because people put stupid stuff in the browsers. But if we spot a trend, then we can see there's a problem somewhere. And a couple of years ago, I was flying to do a talk at a conference, and I was supposed to change flights at the Paris Charles de Gaulle airport. Anybody who's been to that airport knows that that's basically the worst possible idea in the world, try to change there, because all the terminals are spread apart. And my plane lands, I turn on my phone, I have about 45 minutes to catch the next flight, so I'm already worried what's going to happen. and my inbox just starts downloading a torrent of emails from our alerting system where something's gone horribly wrong. Now, we've not changed any software that day, we've not done any deployments, something's gone horribly wrong. And when I kind of finally find a hotspot in the airport that works, I try to figure out what's going on. It turns out that Google Document Real-Time API changed the order of the messages they're sending us after authentication. So we were usually getting like a document connect and then a session connect. Now we're getting a session connect and a document connect. We're not really planning for something like that. And kind of anybody who tried to open a document through Google Drive failed at that point. Now, the interesting part of this is, in the cloud, the applications deployed in the cloud depend on a lot of third-party stuff. They depend on services that other people provide. And no amount of unit testing, component testing, and stuff like that is going to prevent stuff like that. The risk moved. The risk is in the moving parts. The risk is no longer in the parts we can test before deployment. And I'm not just suggesting something like this is going to happen all the time. Third-party services tend to be reliable in my experience, but these things do happen, and they're not really prevented by the testing we used to do before deployment. In a much more kind of common scenario, software deployed to the cloud deploys on a lot of third-party things that you cannot even test properly locally. If you're deploying to AWS, for example, and your software connects to Dynamo or it connects to S3, when you're running it inside a Lambda function, you can do a ton of testing before that, but you can't really test for IAM privileges. You can't test for a lot of the wiring that's actually the risk. Once you start deploying, you actually need to deploy to start testing there. So the risk is actually, for a lot of what I do at the moment, moved from these small isolated code units to the moving parts of my software. And on the flip side, there's a lot to be said about performance of testing in the cloud. People complain how they can't properly test integration locally because you can simulate a Dynamo database or you can simulate S3, but you can't really test how it works before you deploy. On the other hand, deploying to the cloud and testing stuff that's deployed opens up the possibility of running this thing massively parallel that we didn't have before. Like lots and lots of teams struggle sharing one testing environment, or lots and lots of teams struggle sharing, 2 or 3 things they can test between all the developers. But if we plan for testing a part of the pyramid once it's actually deployed, that can run in parallel. Everybody can have their own environment, and that can be very, very easily coordinated. So I think rather than thinking about the best practice that we had before, it's worth thinking about the principles underlying these practices and trying to see how would we implement those principles in the cloud, and what kind of stuff opens up that we can do that we couldn't do before. So we're kind of thinking about this quite a lot, and I think rather than thinking about preferring fast isolated tests, or we should think about, well, let's make sure that the tests run quickly and it's easy to get feedback. It doesn't matter if they're fast and isolated locally, but if we can run them quickly, parallelizing massively on the cloud, that's the same thing. It's actually the underlying principle. We can do another implementation of that. Also, instead of thinking about, well, let's focus the scope on the code units, we need to figure out how do we do the tests that actually cover the big risks, and where are the risks now? What kind of risks are we exposed to? Likewise, kind of thinking about reducing the reliance on slow, fiddly, and integrated tests. Well, that's all because when tests are fiddly, when they're integrated, then they cost a lot to keep updated and change them. Can we raise that level of abstraction and say, well, we want to make our tests resilient to change, not necessarily avoid integration? Can we have integrated tests that we need to have to cover the big risks that are also easy to change? And we've made some really interesting conclusions about this. I'll talk about this later, that might inspire you to maybe look at your testing system. So the first rule that I think we really need to start thinking about more than, prefer fast isolated tests is, let's go and test where our risk is. And in a lot of the cases, at least for what we've been started doing, most of my deployments now are on serverless functions on AWS. yes, we can cover a ton of risks before deployment, but there's still a massive amount of risk that we can only test once the application is deployed. Because of the integration of different services, because of security wiring, because of the wiring between services, because of configuration of environments, that's where a lot of our risk is. So kind of cutting off the top of the pyramid no longer makes sense. Now, one of the interesting things I mentioned that opens up is once we start actually doing deployed tests, we can have as many environments as we like. If 10 years ago, I remember, working with large teams at banks and getting a different testing environment was a 9-month to a 1-year process. That's not something you can do very easily. And that's why lots of teams share the same UAT environment where they cause problems for each other when they test. But with, say, Lambda functions or Google Cloud functions or Azure Cloud functions, they're usually priced per request. So if your testing suite sends 10,000 requests, it costs the same to send it to one environment as it costs to send it to 10 environments because it's priced for the request. Even better, if you have 50,000 users on your site at the moment or 5 million users on your site at the moment, it costs you exactly the same to get everybody on the same environment or to get everybody on 5 different environments because it's priced per request. So what AWS has done is they've opened up this possibility for deployments to actually deploy multiple environments at the same time. And all you need to do is basically do this deployment preference thing in your deployment scripts and say, my deployment preference is this. In this case, the deployment preference is run 2 environments and give the new environment 10% more traffic every 10 minutes. So start with 2 environments. First 10 minutes, the new environment gets 10% of the traffic. Next 10 minutes, the new environment gets 20% of the traffic. After that, 30%, and just keep going unless really horrible shit happens. If really horrible things happen, just kind of go back, and just, because you still have the old environment, route everybody back to the old environment and tell me what happened. And 5 years ago, you could only do these things if you were Google or Microsoft or Facebook. Now, a team of 2 people can do this stuff. And phenomenally, it doesn't cost anything more than just running a single environment once you deploy. So what that looks like basically is when it's being deployed, you have 2 environments, you can see the traffic shifting, you can inspect the new environment, you can look for things, you can look in the logs, you can look in your database to see what's going on and basically roll back. Even better, you can tell it, what does it mean shit happened? Because you can create an alert that's fully automated and you can just say, well, check that the new thing is not generating exceptions. If the new thing is generating exceptions, roll back. And this is a very easy technical check. You can inspect the logs, you can check the number of errors in the logs and things like that, or the monitors. But what this also opens up is a wonderful opportunity to look at what are our risks. What is the risk we're doing with this deployment? For example, if I'm changing something in the system, maybe there's a risk that we've broken our user funnel. Maybe there's a risk that people are no longer converting as much as before. We cannot test that before deployment, we don't have real users, but with real users, we can test. Are people still converting from anonymous to registered as much as they were before? Are people buying as much as they were before? And actually, you can just define an alarm. If you have these metrics, if you have a database with that, you can define an alarm that says basically, check for a drop in sales. I'm going to run my new version of the app in parallel with the old version of the app. If people are buying less on the new version of the app, I have a bug. Or at least I have something that needs to be investigated. And none of my unit tests or integration tests or component tests are going to prevent that, but we have a problem here. We have a problem that somebody needs to investigate. We can't do that before deployment. We can very, very easily do this now after deployment. And this is totally crazy. I think this is a wonderful opportunity for rethinking where the risk is and what kind of risks we want to test for. So another thing that is worth thinking about, and this is where my thinking has changed quite a lot, is what kind of stuff do we go and automate? Because before I started using these kind of deployments, automating things that were expensive to run in terms of time, or automating things that were not really fully deterministic, we were really skipping that. We were leaving that for manual testing. And a couple of years ago, I heard a story about how the development team tested this wonderful game that my son is obsessed at the moment called No Man's Sky. No Man's Sky is a generative universe game that creates something like 18 quintillion planets. And each of these planets is supposed to be playable for months and months and months. It's supposed to be interesting. It's supposed to be visually appealing. And the way they've approached it is they've modeled lots of different types of buildings and animals and landscapes, and then they mutate that to create interesting variations on different planets. So, for example, on this planet here, the turtles are going to walk on two legs and they're going to be red. And on a different planet, the turtles are going to be something completely different. And you can see kind of this looks like a mix between a chicken and a turtle for some reason. And how do you even test this stuff? What does correct mean here? And for example, if you look at that animal that looks like a mix between the kind of alien and, I don't know, a dinosaur, it has really thin back legs. It doesn't make sense. It's going to, it physically doesn't make sense. And they wanted to prevent things like that. So what they've done is they've built this probe that flies through the world. It kind of lands on random planets. It films what's happening on these planets and it streams it into the development room. And they had a bunch of screens in the development rooms where these things would play all the time. So developers, while working on the code, would kind of just watch these screens in the background, and somebody would occasionally say something like, oh, this is weird, this animal cannot stand like this, we have a bug in how we're kind of mutating this animal. They would stop, inspect, look at this, rewrite it, and then run the whole thing again. So instead of kind of just saying, well, this is completely non-deterministic, we can't really automate any testing of this, what they've done wonderfully here is they've looked for ways to automate, to reduce the burden of manual testing. A machine is not going to be able to say this animal doesn't make sense, but the machine can prepare the data for a human to look at it and make it easier to do that. So I think, and rule number 2 we started doing on our software is basically when we approach test automation, we don't really aim fully to replace people with test automation. Although, as a very small team, automating as much as possible is wonderful, but I think there's a higher principle there. The principle shouldn't be automate to replace people, it should be automate to assist people. And what that means is we're starting to look at things, even in non-deterministic tests, that maybe are deterministic parts. So data setup could be a very difficult, very laborious task. For non-deterministic tests that takes a long time, we can automate that. Maybe the machine can't say if something's right or wrong, but I can automate the part where a machine can pump up the data and prepare it and cut off a lot of my time. Also, cleanup tasks, waiting, alerting, and things like that, they become really, really interesting as things that we can automate to maybe get something that's 90% there or 99% there, that we were not even thinking about automating before. And this brings me to a really important conclusion we had when we started doing these things, because previously we would look for easy ways of automating things, and sometimes we would sacrifice how we're looking at a certain test in order to get it automated easily. And I think one of the most important conclusions I had was kind of we shouldn't really sacrifice the perspective of a test for easy automation. If there's 3 different ways of automating something, and one way is very easy, but it doesn't give you a good perspective, that's actually not a good test. And we had a bunch of these things because we were still thinking about the bottom of the testing pyramid. Here's an example. So in the collaboration tool I've mentioned, we do a lot of SVG rendering. We create a bunch of documents all in SVGs that gets rendered in different ways to PDFs, to kind of screen and things like that. And we had a bunch of tests that basically look like this. So we have some setup there that creates a document with a specific theme. We, in this case, put a title on a node and put a label on a connector in a certain color. And then we would look, in a very small code unit, what kind of SVG does that create? And we had thousands of these tests. So some were more narrow, some were wider, but this is kind of thousands of this stuff we're testing our system. And from a kind of testing pyramid perspective, this ticks all the boxes. They're small isolated unit tests. They're kind of relatively easy to update. They are deterministic. The problem with these things is once we started changing themes, once we started putting different fonts there, very, very small movements in these things caused us to go and have to update thousands of tests where we would have to manually recalculate these positions in the SVG. It was really, really difficult to say, is this right or wrong when a test fails? So when the test passes, we know we didn't change the system. When there is a change, it was really, really difficult to know if the change is good or bad. And at the end, what we ended up doing is kind of doing some visual inspection tests and then running this thing, just capturing the SVG coming out and putting it back into the test. At this point, kind of the whole purpose of the testing failed because we're no longer trusting our tests. So what we've done is basically cemented our code instead of made it easy to change. And then we had this real epiphany once there was a requirement we had from a university to implement for their students. And we didn't really know the business side of it. So we had to go and do customer research. The requirement we had was not just do mind mapping, but also do concept mapping. And concept mapping is kind of non-hierarchical. It's basically allowing people to connect different concepts with lines that have some text on it. So this is a concept map, a trivial one. And when we started looking at this, we had some questions we didn't know how to answer from a business perspective. Like, okay, this is easy like this, but what happens if the text cannot fit on the line? Should I truncate it? Should I word wrap it? If I word wrap it, how should I word wrap it? How thick should it be? Should it look like this maybe or not? Also, once you start creating more complex relationships, there's multiple options that we did not know which one to choose. So say if you don't have just 2 nodes, if you have 3 nodes in the play, should it look like the thing on the left or should it look like the thing on the right? That's a business model question. That's kind of a domain question that we didn't have expertise in. So what we did is we actually organized a Kano survey with the users that are interested in this. A Kano survey is a wonderful product management technique, product research technique that gives people opposing options and then asks a bunch of questions like, would you expect it to be like this or would you expect it to be like that? How would you feel if we didn't support this? So there's a whole kind of matrix there, how to draw conclusions from the survey. I'm not going to go into that now because that's off topic, but effectively we created a survey like this that offered 2 options and then let people choose. We sent it to about 700 people. The results came back, we put it into the matrix and we had our conclusions, what we needed to do. And what I realized is that this is the perspective of the testing that we actually need to deal with. Not the SVG stuff. The SVG stuff is irrelevant. If I draw an SVG in one way or another, but it looks like this, it doesn't really matter. If the things move left or right, if I had something like this to look at, I could conclude very easily, is it right or wrong? Like the No Man's Sky thing, a machine might not be able to decide if something is right or wrong, but if a machine showed me something like this and said, look, this is how it used to look, this is how it looks now, I can decide if the change is good very easily. And I can automate everything else apart from deciding whether this is good or bad. So that's actually what we did. We built a small tool and we open sourced it. I'll give you a link later. that allows us to create tests like this that run the whole integrated thing with the browser, take a piece of screenshot, compare the difference, and tell us if this is good or bad. So this is what a test looks like in that testing tool. The fixture is the automation part, and basically the fixture takes this example. An example has a name, and the example has some properties. In this case, the property is a label that I'm putting on a default thing, and it's matched with a label on a markdown image. So the example name and the image name need to match. And this is basically saying, once you run the whole thing with this particular property, I expect it to look like this. If it's the same, just don't tell me anything. If it's different, show me the difference so I can make a decision. And it's relatively smart how it does clipping. So in a case of a failure, this is what it would look like. It would say, look, you expected the thing on the left, the actual thing is the thing on the right. Now, tell me if this is good or bad. And if this is good, just approve it. And this clip becomes the baseline for the next test. If this is bad, you have a problem, go and solve it. And you can also see the diff on the kind of bottom left corner that's telling you, focus on this when you're evaluating these images. That's what's different. So this allows us to run lots of really wonderful tests, like how does a website look, landscape-oriented, portrait-oriented, lots of different resolutions. How does a website look in this way? How does the app look like this? How does the app look like that? We can focus on different parts of clips. Now we have thousands of tests like this. We have visual unit tests that focus on a small piece like this. We have visual integration tests that look at a larger thing. And the whole thing is very much end-to-end. It runs it through a browser. It takes a screenshot. It's slow, but we can run it massively parallel. And even better, because this is Markdown, we get good documentation, what the system is supposed to do, that renders nicely in our GitHub repository. The page you're looking at now is a fully automated test, but it's also a documentation page that says, well, you know, if you have just a default theme, if you have a default theme and a background color, if you have a default theme and a corner radius, this is what these things are supposed to look like. And this is a fully automated test that, you know, I can run. If the thing is the same as before, no problem. If the thing is different, it will show me the diff and let me know, is this good or bad? So we had a very big change, changing the default font actually a few months ago, and it broke all the tests, but it was very easy to just go and review these things and say, well, the diff is only in the text. That's fine, just approve. And what this allows people to do is start with a drawing. Start with something that's mocked up, a pencil drawing, a wireframe, run it, the test will fail, but then it will show you what you expected and what it actually does. And you can say, well, yes, this is kind of what I meant when I was drawing. Or you can start with an existing screenshot and kind of color things in with the pencil and say, this should change. Then a designer can look at it and say, well, yes, that's what I expected it to do, approve. Or no, this is wrong, let's do something else. And what we've also kind of figured out is we should be able to just run this thing without an expectation. Create an example, run it. It will just tell us, look, you've not expected anything, this is what I got, is this kind of okay or not? And it allows us to create tests like this very quickly. So the rule number 3, I think I want to really propose is that the automated test must be designed to facilitate change, not to cement code. The SVG tests we had were ticking all the boxes of the test automation pyramid, but they were cementing our code. They were making it difficult to change. They were keeping the code in place. The stuff we have now is making it very easy to change the code. It's good documentation, it's easy to update, it's easy to maintain, but it's not kind of a small unit, it's a massive thing. And once we started doing that, we started realizing crazy opportunities for other things as well. For example, the product I'm working on at the moment, I've launched it commercially a few months ago, is a tool that helps developers build videos from Markdown. It allows you to create a video source and keep it in your version control. It allows you to embed videos and resources and things like that. It's called NaraKit. And it uses a ton of cloud services to do this kind of stuff. The risk is mostly in the moving parts. It actually even allows you to use lots of text-to-speech services online that can create lifelike sounding text. It's amazing how technology is advanced there. So, it can do English better than I can. I can't get rid of my Bond villain accent, but the videos I can create with this have actually much better English. And the source for a video looks like this. So I can say, look, get the first 10 seconds out of this screencast, generate the audio based on this text, and then synchronize the video to that, speed up the video, slow it down to actually match the duration of this, then kind of do a transition to a next scene where, take this image, resize it to cover the whole video, and then tell this stuff. So this allows us to create very easy promotional videos. It allows us to collaborate on videos, and it's kind of version controlled videos. This is insane. And it allows us to actually do a ton of stuff where we have a CI pipeline for documentation videos. If we change something in the app, we just take new screenshots and we generate new videos for this automatically. But how do we test this stuff? This is really kind of another one of these weird challenges, because it depends on third-party services that generate audio. It depends on third-party services that recode videos. It's just, the risk is in the moving parts. And what I realized is that, I can take a video and make an image out of it. FFmpeg, the open source video toolkit, allows you to do something like this. It can take snapshots of the video at certain points. It can even put like the code, time code on top of it. And then I can take the audio and transform it into a waveform and dump it on the bottom. And from a resulting video, created an image that I can do all the kind of same testing that I'm doing on the website look and feel with this stuff. So, for example, this is again a documentation page and a fully automated test. And it basically says if I'm rendering a slide on top of a video, this is another feature we built. So I can do a markdown slide. I can put it on top of a video. It should look like this, with this video and with this slide and in this resolution. And then if I change something, for example, if I change the font sizing and the test fails, I can very easily see what to focus on when I'm evaluating this stuff. And we really realized that if we wanted to do this properly, we need to focus on optimizing the human time in the whole equation. Automate to assist humans. So what's everything we can do to bring it to the point where a human can say yes or no? And we realized that having a good way to diff is really, really important. So in this case, what I can do is overlay expected, actual, and the diff. I can turn these things on and off. I can play with opacity to actually see what moved. And it very easily allows me to say, well, yes, I've changed the font sizing. This is what I expect to happen. Or, no, this was never expected to happen. Something broke. Let's go back and fix it. So if you start building your own tooling for something like this, and not just for visual testing, if you want to do visual testing, use the tool we open sourced, but if you want to start building your tooling around these kind of principles, then I think the really important rule number 4 needs to be optimize the diff. Invest as much as you can in figuring out how do we show a human what's different, so that they can focus their attention on this kind of stuff and make it easy to spot changes, make it easy to act on the changes. One of the things that we've taken from approval testing as a process is make it basically easy that a failed test result can become the expectation for the new test run. That makes it really, really easy to spin up new tests. It makes it really easy to reduce this kind of approval cycle. And this kind of brings me to the next point I've mentioned earlier. If we run tests in parallel, if we run tests when they're deployed, we can make tests that cover the big risks. We can also look at things that are optimize the diff, optimize the human time to get feedback, but it's still really tricky to make tests resilient to change. If we change some implementation, how do we avoid breaking the tests? So this brings me to the research I've done for the Spec by Example book 10 years ago. And in the research, I spoke to a bunch of teams, and there was a recurring topic over and over and over again that people who figured out how to split the kind of test definition and the test automation and get good results usually said that kind of the test definition ends up describing what the system is supposed to do and not how it does it, as opposed to the test automation part that's only supposed to describe how the system does something without describing what it's supposed to do. And splitting it into two different layers like this becomes really interesting as a way of avoiding all these tests that are difficult to maintain. So for example, a test that says, click here, 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 check this button. That's mixing what and how. And people then complain UI tests are difficult to maintain. There's nothing to do with whether it's a UI test or not. It's mixing what and how. If we say a person who purchases 10 items is allowed a 5% discount, that's the what. The how part can be click, 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 and still go through the user interface if it's required. It's still a UI test, but it becomes much, much easier to maintain because once we change something in the system, we only have to change it in the automation piece. All the tests kind of keep working the same. So the stuff I've shown you so far, it kind of works this way. When we moved from SVG tests to visual tests, we started testing what we want to look at rather than how the system does it. When we started looking at rendered videos and stopped testing command lines and integration calls to other services, we stopped testing how the system does something, we started testing what it does. And the whole kind of idea with the deployed Lambda, if we're checking for alerts, are the customers still buying as much as before? That's what the system is supposed to provide, not checking all these things. So kind of coming back to the title of the session, you're testing what. Rule number 5 is you should be really testing what the system does, not how it does it, and splitting these two things. And I think kind of if we focus on testing what the system does, we make it very, very easy and resilient to change because the business rules stay the same regardless of how we're implementing it. If we are kind of focused on optimizing the human time, then we can automate a ton of stuff people didn't even think about automating before. And if we're thinking about actually kind of deploying and running these things massively parallel, the whole problem of kind of these slow running tests kind of goes away. So that's as much as I have time for you today. I'm slightly overrunning on time, so don't think we're going to have time for questions, but I will be monitoring the Slack channel of the conference for the next half an hour or so. So if you want to ask questions, let's ask there. Here's a couple of links for you. The tool I've shown you that does visual testing is open source, and you can grab it from appraise.qa. If you're interested in version-controlled videos, and if that sounds like something that would help you, check out nerakit.com. That's my latest product. I blog a lot about these things, and you can find more details about kind of stuff I talked about on my blog at gojko.net, and you can download the slides of this presentation from this link that I've also pasted in the chat. So thank you very much.